Sir? Sir? I think you are muting yourself, sir. I cannot hear you. Sir?
Now, I'm very, very sorry that you couldn't hear anything. Can you hear me now? I was recording and you couldn't even hear. Can you hear me now?
Yes, sir. Yeah, sir. Thank you.
Anyways. Yes. Okay. So the problem was my microphone was turned off. Can you hear me now? How about now? They probably
Yes,
gave
sir.
up.
Yeah, I can hear you now.
They're gone. You know, I think that person left. Can't find who? Yeah, this is lecture 5. All right, so sorry about that little sidetrack. That's my fault. I've been married for 20 years, so I know everything is my fault. That's the default position, right? That's why they call it default. All right, so if you're going to solve this problem, you need to know what things can help you. I guess that would be items. You need to know what your enemies are. What are the enemy's weaknesses? How can I disable the enemy so that the enemy doesn't kill me? That's what I hate about these computer games. I'm listening to my kids all the time, you know. Oh, I just died. Oh, I just killed you. I'm like, what? What are you guys talking about? But you know, that's what they say. And then after they just died, then they're playing again. So I guess you didn't just die. Thank God for that, man. You had me so worried. Anyway, so there's a lot of things that you need to know so that you can get to the end there and so that the enemy doesn't destroy you, I suppose. Yeah, my son, when he's playing the game, right? My son, he's 19 now, but I call him vampire because, you know, he's not up during the day. He's only up all night long. And then, you know, I wake up at 4 o'clock in the morning and I wake up and my son's downstairs and he's shouting, hey, he's going to kill you. Oh, I just killed you. Oh, I just died. I'm like, what? What's going on, man? Is there a burglar in the house? It's a computer game. You guys don't do that though, right? Anyway, so there's a lot of things that you could do that would help you to win that computer game. These are some of the questions that you would answer about that. This is kind of like a computer game. This is what we're doing. Oh, sorry, come back. What we're doing here is we're going to do, all the green stuff goes in the green area, but that would help you to know, right? But let's start on here, computational thinking. Which one of these blue things here would be decomposition? Focusing on important? No, that's not it. What would focusing on important stuff be? Not looking at unimportant stuff. No. Try again. Focusing on important information. Which one is it? Decomposition, pattern recognition, abstraction, or algorithm? Abstraction. Good answer. Thank you. So focusing is abstraction. Step-by-step solution. It's not pattern recognition. Algorithm. Thank you. Sorry, it's going underneath, but you get the idea, right? That step. breaking it down into, very good. And last but not least, similarities. There's your pattern recognition. There you go. Sorry, it's hidden by those other ones. But yeah, so we got that one done. And we can do that with these other ones as well. When you're going to meet up with people, you need to know where you're going to go, what you're going to do, what transport's available. Get the idea, right? All those green ones go there. What options are we going to go? Are we going to go jet skiing? Are we going to go quad riding? Are we going to go and break our cars in the desert, right? One of those. Or are we going to go to the pizza place? I don't know if I could do that, but that's an idea. You could try that. Download this. Anyways, to be honest, I don't really care about this too much. I'm just putting them there. We get the idea, right? But, you know, Omar's got a nice idea. What if we made the table bigger? I don't know. Yeah, it's not working for me. Anyway, so this is what it looks like if you made it organized, like making it bigger, like Omar said. Right, so we got that there. I hope that makes sense. Breaking things down, that's decomposition. Pattern recognition, we see similarities. Abstraction is we focus only on the important stuff. Disregard the not important stuff. Algorithm, step by step, that's algorithm, right? There's a transport. Okay. Decomposition. Which one of those is it? Decomposition is breaking things down into simpler. Great, great. And so we had a big problem, which was complex, still going, ongoing problem. The complex problem was people getting sick, filling up the hospital, some of them dying, getting real sick. So they got stuff in their lungs, and then they have to have respirators and they have to have special medicine. And so we knew that this disease is infectious virus. And so what can we do to stop infectious viruses? Well, we could stay away from each other, like I'm staying away from you. We could wear a mask. Staying away from people. Could we use a computer to help us stay away from people? Yeah, well, we could have a thing called INFS. And how INFS would work is if you got the disease and they know that you got the disease, you get a red thing. And so you can't go into the school, you can't go into the shop, you have to stay home. So that makes you stay away from people so they don't get sick. So there you go. That was a nice little program that doesn't solve the problem because the problem is very complex. The problem requires really smart people, lots of them, you know, doctors and nurses, computer people. The computer people can help a little bit. They can give us an app which will tell people that are sick to stay home. Yes, what was your thing? In Australia, they call that let it rip. Yeah. All right, so I would love to talk about that for like 3 hours, but then I wouldn't finish the lecture. So let's go on from that. That's nice. Now, you know why we're doing it. I mean, I've had 3 injections. You know, they're going to give another one and I'll have another one. The only reason why I'm not wearing a mask now is because I did talk to you guys. You said you were okay with it. And I'm trying to stay away from you, but I can't really talk with the mask on. It makes me lose my breath and then I'll run out of time. But what I was going to say about that is the whole thing about this having the injections. I've never been worried about that I'm going to die of COVID, but I don't want to go to hospital. You know what I'm saying? And you don't want me to go to hospital because there might be somebody else who is really sick and they need to be in hospital and I want them to have the bed. And so I don't want to go there so that they can stay well. And that's the other thing. Yeah. Going to a hospital, that's where all the sick people are. So why would you want to go there? Right. Good point. All right. So Omar always has some good thing to say. I appreciate that. So where do we start? Where do we start? We start with the first step, right? The journey of 1,000 kilometers or miles starts with the first step, but we have to decide where that step is. And that's going to require some thinking. It's going to require some creativity. it's going to require all these things that we're talking about in here, the composition, meaning breaking things down into smaller parts. So as it says here, you just brought back a box from IKEA. Where do you start? If you like to solve problems, you'll just look at it and you'll figure it out. If you don't like to solve problems, you'll notice that the IKEA thing comes with a list of instructions. And you just say, number one, all I'll do is start there. Because even though it's all in Swedish and you can't read the words, you can read number one, number two, number three, and number four, right? Everything is pictorial, right? And that's the other thing, IKEA, they're such a clever company. You know, Swedish, right? But you bring the thing home from IKEA and you don't have the instructions. I don't know why. Maybe your dog ate it, right? Like your homework. So you don't have the instructions. So what do? You go online to IKEA. You put in the name of the thing. There's the instructions. Comes out. Oh yeah, it's all online. You don't have to worry about those bits of paper. It's all online. You can probably even find a YouTube video of somebody showing you how to do it. I don't know about that. I'm just guessing. But I know that the instructions are online because I've seen them. All right, so where do you start? Yeah, all right. So the thing is that, as it says here, you start with some creativity. So the way that you're going to sort of actually complete this would be different for each person. So we write computer programs, and teachers like me, we mark the computer programs that the persons have done. So one of the things that we notice is, you know, people, when they write programs solving the same problem, they will do it slightly differently. They'll use different names for variables. If I see two programs that are exactly the same, I'm probably going to start asking them questions. You see what I mean? Because everybody does things slightly differently. That's our creativity. That's really a really good thing. All right, so there's this guy by the name of Polya. I don't know if he's still around because he wrote this book in 1973 and he had the idea in 1945. But basically, if you look at what's on the left and what's on the right here, you'll see that Polya came up with this idea, which seems to work on the basis of the scientific method. Scientific method is very old. We got that from like Aristotle 2,500 years ago. So that's been around for a while, but he's sort of come up with this thing that works based on it, I think. And I say it's based on it because if you look, there's a sort of relationship between what's on the left and what's on the right. This is his idea on how we solve computer problems. Understanding the problem, it's kind of like forming a hypothesis. Forming a hypothesis in the scientific method, what we do is we say, I think I have observed these things, and based on what I've observed, I think this is happening. Then as a scientist, what they'll do is they'll plan some experiments. The idea of those experiments is to try and prove that what I think is happening is not happening. Now, I know that sounds strange, but that's what we do in science. We say, okay, I think this is what is happening. Can I prove that I'm wrong? If I can't prove that I'm wrong, then I'm going to say, well, I think maybe I'm right because I couldn't prove that I'm wrong. Then we publish a paper and send it to other scientists. We put it in a journal. The other scientists look at it and we say to them, please try and prove that I'm wrong. Because if you can't prove that I'm wrong, then maybe I'm right. And I want to be right. But I won't know that I'm right unless somebody tried to prove me wrong and wasn't able to. And not just somebody, unless nobody was able to prove me wrong. Then I'll know my idea is right. Then I have a theory that works. So that's how we do science. We execute the experiment. We publish that. Other people look at it. They will try it. And if nobody can prove it's wrong, then we're going to think it's right. Until, I don't know, 100 years later, somebody comes up with a better experiment and they're able to prove it's wrong. Right? That will maybe happen. And then, okay, then we have a different theory. Now, in building a computer system, so what we're going to do is we're trying to solve problems, but we can use the method. Now, there's some other slides here in this lesson where we talk about a detective, at a crime scene. Detectives, scientists, computer people, we're all kind of doing the same thing, right? We've got a problem, we want to solve it. We kind of do it in the same way. So this is like the hypothesis. Then we devise a plan. We got a problem. What would be our plan for solving that problem? Execute the plan, then review it later, because maybe we're going to come up with a better plan later. Maybe. I don't know. Don't panic. Yeah, all right. So don't panic because the problem's so big. It's overwhelming. No way I'm going to solve this problem. So what am I going to do? I'm going to break the problem down into smaller parts. That's our decomposition. When I've broken the problem down into smaller parts, then I got something I can work with. Maybe I can solve it. Don't start writing computer programs. Okay, I got a hammer, everything's a nail, right? I know how to program in Python. So yeah, I'm going to start writing Python codes. You give me a problem, here comes a Python program. That's not the way we want to do it. We want to spend a lot more time on actually understanding the problem before we try and start to make a application to solve it. So the idea here is undesirable and desirable. So the idea is that we have a state which is undesirable. We always have a state which is undesirable. Otherwise, you're going to be out of business. You won't be a computer programmer, right? Somebody has something which is undesirable. They want it to be different. They want to get their information faster. They want their information to look in a different way. Something like that. What they have at the moment, they don't like. They want something else, right? And that's our life, right? Right now, your life is undesirable. How do I know that? Because you're sitting here. You're sitting here because you want to have a degree. At the moment, it's undesirable. I'm a 20-year-old and I don't have a degree. I want to be a 22-year-old with a degree. That's desirable because I want to have a job or something like that. And so you have decided that that's my problem. I'm going to solve that. I'm going to break it down. I'm going to apply to go to a university, college, and I'm going to study. I'm going to do this course, that course, that course. I'm going to get this GPA, and then I'm going to have my degree, and then I'm going to have my job. And then I have another problem, right? Well, you ever run out of problems? No. You just have another bigger problem, but at least you'll have some money that you can apply to that problem. So we're solving them as we go. On your way to getting your degree, you're going to have lots of little problems. So, and they'll come in the form of, here's a project, right? Yeah, do this project, do that project, do this assignment, do this test. Little problems. Every day you're going to have them, and you can use the same kind of way of solving them, right? Okay, so that's my desired state. My desired state is an A+ in that assignment. My current state is I haven't done the assignment. That's undesirable. I want to get to there. This is probably the things that I need to do to get that A+ in that assignment. Okay, here's my plan. A good plan is not the day before the assignment is due to stay up all night and try and do it. It might work for some people, but probably a better plan is the day that the assignment is given to you, that I write down a plan. These are the things I'm going to do tonight, tomorrow night, etc., to get that assignment done. I think you get the idea on that, right? I'm running out of time because I talk too much. All right, so trying to understand a problem. It's foolish to answer the question that you don't understand. Spend more time trying to understand the problem. And then the actual solving of the problem will come quicker and easier for you. The purple stuff is kind of more important, I guess. That's why it's purple. Did I get the right problem? Yeah, I don't know. Anyways, so yes, I did. Let's read that. Whatever the problem, the key thing to remember is the goal defines what needs to be done. The goal is the desired state, having the degree. Thinking about the details like designs and algorithms at this stage is too early. So when you decide to come to college, you weren't thinking about, oh, I'm going to do, this kind of program in that course. You weren't thinking that. No, you're just thinking, okay, I need to get that degree. So I'll take it step by step, right? Now that you're in this class, now you start thinking about, this is what I need to do to prepare for that quiz. This is what I need to do to hand in that assignment, etc. So yeah, so we didn't worry about that until we defined the fact that we wanted to be there. Here's an example of that exactly, I suppose. We need to have so imagine you're an event organizer and you need to organize a conference for people to come and speak. The idea here is there's some things that we need to focus on at the start. There's some things that we'll focus on later. So they're going to kind of go from a broad, top-down view, basically. They were looking at the whole thing to the specifics. So I guess the question would be, the first thing you do, decide what food you're going to have at the conference? No, I like that answer. Thank you, Hafsa. No, you don't decide that. You can decide that the night before the conference, right? You could send out an email to everybody. What kind of food do you want? You want pizza? You want shrimp cocktails? It wouldn't really matter. Most people, as long as it was some nice food, they'll be going to be happy with it, right? So that you can leave until later. Where are we going to start? With the seat chart? No, we can't do the seat chart until we know who's coming, right? Possible list of guest speakers. No, we can't do that until we know what the topic. So, I mean, I think you get the idea. We need to start with the overall. What is this conference going to be about? We decide the topic, then we can decide on, who's going to, be the guest speakers. Then we can decide on how many chairs and where we're going to put people. Last thing we're going to do is decide which food, which company that could come before which food, obviously, because it's going to take time to do that. More purple stuff. Purple stuff seems to be important stuff. To help you better defining the problem goals, always write them down. Yeah, okay. All right. That's sort of motivation 101 or something like that. A goal not written is only a wish. You ever heard that before? All right. So I'm a motivational speaker now, right? By the end of this course, you will all have $1 million in your bank account. A goal not written is only a wish. Yeah, okay, whatever. I just leave it at that. It's too much fun, isn't it? I mean, I don't know who wrote these notes, but they're kind of fun. We came across a crime scene. If you're a policeman and you're a successful policeman, okay, we're talking about detectives now, right? You would probably do things in a organized, logical way. And so you're a policeman, you come across a crime. One of the things you're going to do is observe a lot, right? And so the idea in this graphic is there's certain stuff that you'd want to notice. And we don't call all of those things together evidence, but some of it is physical evidence. And some of it is testimony evidence. Anyway, so what do? We need to know what crime is committed. We could see that maybe by noticing that some jewelry is missing from the jewelry store. When the crime was committed, well, we have some time. Maybe that would be there somehow. Where? Well, we can see that. We got some evidence there and some physical evidence of the footprints. And we got a witness, so that's testimony evidence. Yeah, anyways, if you were a detective, you would go and ask all those things, right? So it's the same with solving computer problems, I guess. Yeah. Who? Clean up the area? No, seal off the area. Yes. And the reason you seal off the area is because it's a crime scene, so you don't want it contaminated. You don't want people messing with the evidence. Yeah, all right, good. You could be a policeman. Yeah, me too. I like all this. I don't know why, but they have all these shows about people that are killing each other. It's like my kids watching computer games, right? And the first thing they do when somebody kills each other, what they do, why? I mean.
Because blood. It looks good. It doesn't look good.
And you imagine things, right? I notice these things, there's always a pattern, right? So-and-so dies. The police goes and talks to the husband or the wife if it was a man who died, right? And then you find out that there's a big life insurance policy. Crime is solved, right? At that point, the crime is solved. Not sure I understood that. Yeah. Yeah, okay. If you can answer this stuff, then you can go and work at Subway. All right, so because when you go to Subway, they don't have a sandwich. They just have a bunch of stuff, right? They got some bread over there and some stuff over there, and they ask you some questions. So they are actually following an algorithm, which is the how to build a sandwich algorithm. And it's kind of like computing. You could probably write a computer program to do this, right? The how to build a sandwich algorithm. What bread do you want? Person types in the type of bread. What do you want, butter or do you want mayonnaise? What do you want on a sandwich? Boom. Oh, the robot goes, out comes the sandwich, right? I think you could get a robot to do the sandwich thing at yeah, they're all going to go and take study to do computing to make programs to make robots. Okay, I'm going to end this now, and we're going to take a minute.